So we're going to start basic matrix operations. A matrix is just a rectangular arrangement of numbers in rows and columns. Elements, Elements are the numbers that are in those rows and columns. Rows are read across, columns are read down. Dimensions are row by column. So this is 3 rows. So I would write this 3 by, then you can see I have 2 columns. It's a 3 by 2. What I'd like you to do is pause and see if you can figure out the dimensions of these others. So this guy right here has 1 row, 1 column, 1 by 1. 1 row, 5 columns, 1 by 5. 2 rows, 2 columns, 2 by 2. Matrices are equal if they have the same dimensions and the same elements. I want to create 2 matrices that are equal, so I can see that my dimensions are both 2 by 2, 2 rows, 2 columns, same here. Now all my elements have to be equal, so I'm going to solve for my variables. So this upper left goes with this upper left, so x is going to equal -9. This bottom left goes with this bottom left, so y is going to equal -2. And last, this bottom right and this bottom right are the same element in the different matrices, so z would be 6. So again, why don't you pause this and see if you can solve this matrix? Okay, pause and check your answers, and you see the work. Okay, so now we're going to look at doing some operations on matrices, and the first thing we're going to look at doing is adding and subtracting matrices. Okay, so the first thing you need to know, you can add and subtract matrices only if the dimensions are exactly the same. So I'm going to start by adding A plus B. So again, you're probably going to need to pause to catch up to me. So when I add, since the dimensions are exactly the same, I'm adding 2 matrices together to get a new matrix. So I always add upper left plus upper left gives me upper left. Middle top plus middle top gives me middle top. Top right plus top right gives me top right. And so on. This is a 0. Now we're going to do B minus A. Same as in adding, I am going to subtract. So top right, top left minus top left is going to give me top left. And already in your minds, I hope you're saying, oh, subtracting, I've got to be a little slower. Middle top minus middle top gives me middle top. 5 minus -2. Here's where you're going to get mixed up. So this is going to be plus 2. So I'm going to get 7, and so on. Multiplying by a scalar, I just look as distributing. So this is matrix A, and what I want to do is I want to do 2 times matrix A. And all that means is I'm going to distribute this 2 into each of these elements. So I'm going to do 2 times 1, 2 times 4, 2 times 3, 2 times 0, 2 times -2, 2 times -10, and that would be multiplying by a scalar. I know it's difficult. So now let's talk about multiplying. And this can get complicated, so you just need to do it slow, and if you need to, replay the video. I'm going to try to use as much color as I can. The first thing I want you to do is pause the video, write down these matrices, and write their dimensions underneath. So there's one rule in multiplying matrices that you have to check before you do all the math. It is that the columns in the first matrix has to equal the rows in the second matrix. And it can't be vice versa. So let's look at an example of this. Let's say we want to multiply A times B. A dimensions are 2 by 2. B dimensions are 2 by 2. The middles match. Therefore, the resulting matrix will be a 2 by 2. Let's look at C times D. C is a 2 by 3. D is a 2 by 1. These don't match. I cannot multiply them. But let's look at D times C. This is a 2 by 1 and a 2 by 3. Again, can't match. So let's look at B times C. B is a 2 by 2. C is a 2 by 3. The column matches the rows, so it works. The resulting after I multiply will be a 2 by 3. Okay, so let's do some multiplying. So we're going to multiply A times B. So the first thing I need to do is figure out if I can. 2 by 2, 2 by 2. These match, so my result is a 2 by 2. When I multiply matrices, I always set up my matrix with blanks. I know it's going to be a 2 by 2, so I'm going to have a number here, a number here, a number here, a number here. And when you multiply first row by first column. So I'm going to multiply first row in A by first column in B. Okay? And I'm going to see if I can keep that out. It's going to be really helpful for you guys if you recopy these so that we do all the work on a separate. So what I just did was I just copied A and B down here. Okay, this is A, this is B, so I can mark on it and you can mark on yours. So I'm going to multiply first row by first column. How do you do that? I'm going to multiply the 8 times the -2, and I'm going to add 3 times 3. Okay, now I'm going to multiply, get my right color. Now I'm going to get this element right here. This element is the first row, the second column, and that's what helps me learn. So this guy is first row, first column. So I'm going to multiply the first row with the first column. So I'm going to multiply the 8 with the 5, 8 times 5, and I'm going to add 3 times -4. Okay, now I'm going to do this row, this element right here. This element right here is second row, first column. So I'm going to multiply the second row, the first column, to get that element. So 4 times negative 2, since 4 is the first in the row and negative 2 is the first in the column, I'm going to add 1 times 3. And lastly, I'm going to get this element right here. This element is second row, second column. I'm going to multiply the second row by the second column. So 4 times 5 plus 1 times negative 4. And my new matrix then will be negative 16 plus 9, which would give me negative 7. The next one is 40 minus 12, so that's going to give me 28. My next one is negative 8 plus 3, that will give me negative 5. And the next one would be 20 minus 4. So this would be my new matrix. So let's check out B times C. Can I even multiply them? Well, we know that this dimension is 2 by 2. This dimension is 2 by 3. These match. So my result is going to be 2 by 3. So I'm going to set that up right now. Leave myself a little more space this time. Okay, what element is this? This is the first row and the first column. So I'm going to multiply the first row and the first column. So it'll be negative 2 times 6 plus 5 times 4. This element is the first row, the second column. I'm going to multiply the first row by the second column. So negative 2 times 1 plus 5 times negative 3. The next one, this is the first row, the third column. So the first row, the third column. So negative 2 times 2 plus 5 times 0. Okay, so now pause and see if you can fill in those bottom 3 elements. How'd you do? So let's complete our matrix. And that would be your completed matrix. Okay, so write down this AB. Figure out if I can multiply A times B. And figure out if I can multiply B times A. So here are my dimensions. And these match. My result is going to be a 4 by 4. B times A, these match. My result's going to be a 1 by 1. What is that going to look like? So a 4 by 4, 1, 2, 3, 4, 1, 2, 3, 4. That's huge. That's all that is, a 1 by 1. So let's look at the B times A first, because my result is a 1 by 1, so I'm going to trust my math. And remember, this is first row, first column. So I'm actually going to do first row by first column. So first row by first column. Okay? And I'm going to erase this. So I'm going B times A. B times A. So first row times first column. So negative 2 times 2 plus 7 times 5 plus 10 times negative 2 plus, 6 times 0. And I'm going to get negative 2 plus 35 is 33 minus 20 is 13 plus 0. So this should give me 13. Isn't that weird? Okay, so I'm going to trust my math over here on the left, and assume it's a 4 by 4. This is a lot to fill in, but this element right here is first row, first column. So I'm going to multiply my first row by my first column, and I get -4. First row, second column. First row, third column. First row, fourth column. Pause your video, make sure that you can fill in the rest on your own. Isn't it nice when you have a 0 at the end? Okay, you guys, that's it. Sorry this was so long, but it's a lot of information, new information for you guys in the next couple of weeks. I'll see you tomorrow.